The first general concept is that the original function and the inverse function are reflected over the line y equals x. The second general concept is that the domain and range of the original equation are flip-flopped in order to create the domain and range for the inverse function. The third general rule is that f of a equals b if and only if f inverse f of b equals a. In order to graph an inverse function, you must graph the original function first. You do this by plugging in an x value and solving for y, as Joe is doing now. Once you do that, you plot your points, so that makes creating the inverse graph much easier. The inverse graph is just the opposite of the original graph. The points are flip-flopped. If on the original graph you have 2, 4, the inverse of that would be 4, 2, as Joe is showing right now. When finding inverse functions, there are very many types of functions that you will find for each grade level. For instance, in 5th grade, you might get y equals 5x plus 7. Then you would just switch the x and the y and solve for y. And with this equation, you will get 7 minus x over 5. That would be considered easy. An extra easy one, as Joe is doing, would be 1st grade level. 1 plus 4 equals 5. 5 minus 1 equals 4. A harder one that you might learn in pre-calc would be g of x equals 5 over x minus 6. And you do this very same thing here, you just switch the x and the y and solve for y. So you get g inverse of x equals 6x plus 5 over x. That would be a more difficult problem. A problem that you might find in calculus class, considered a hard problem. Y equals sine x plus 1. Again, you switch the x and the y, and you solve for y. So for this problem, you get f inverse of x equals sine inverse of y minus 1. For a real-world application, temperature is often used as an example. For the original, you are trying to find Fahrenheit, as shown right here. In order to find the inverse of that, you need to find the Celsius temperature. So with that said, you would switch the fraction to make it 5 over 9, and then you would switch the plus from the original 32 to minus 32 in order to get the inverse. F inverse of f equals 5/9 times the quantity f minus 32. In order to find the derivative of an inverse function compared to its mother function, you must first start out with an original problem. With that problem right there, then you must find the inverse of it, as shown how to do right in front of you. From there on, you must find the derivative of the inverse, which is shown in red. That is the inverse compared to the other function.